Okay, so we're going to prove that if the altitude for vertex A in triangle ABC is also the median of BC, then AB is congruent to AC. So let's go ahead and start the proof. Okay, so let's go ahead and draw that line. That's going to be our median of BC and our median of BC and our altitude. So and let's call that AD. Oh. So AD is an altitude, implies that the measure of angle ADB is equal to 90, which equals the measure of angle ADC. Right? Okay. So we know that it hits BC at 90 degrees, AD hits BC at 90 degrees, and since we know that AD is the median of BC, this implies that BD is congruent to CD, right? So we know that this is congruent to this. So look at what we have in the picture. Go up a little bit. We have side, right? If we were to look at these two triangles, we know they're congruent because we have side, right? Angle and side. So by the side angle side congruency postulate, we know that these two triangles are congruent. So let's go ahead and write that up. So we know that AD is congruent to AD. We know that ADB, so angle ADB, is congruent to angle ADC. And we know that BD is congruent to CD. So these three things imply by the side angle side congruency postulate that triangle ADB is congruent to triangle ADC. And if these two triangles are congruent, that means these corresponding sides are congruent, which implies that AB is congruent to AC, which is what we set out to do. This implies that AB is congruent to AC. And that is the proof.